To the review sheet help class, pre-calculus students. There's the review sheet in front of you. Let's go ahead and get started. Get your books open to page 505. And we're looking at numbers 1 through 41 odd, so we will start there first. So again, have your books open, 505, have your notebooks out, calculators, notes, whatever you need, and let's get started. Number 1, they want us to take this ordered pair, the directions say, and reflect it across the x-axis, the y-axis, and the origin. I'm not trying to be sloppy, but at the same time, I think speed is very important in trying to save time. So we know negative 3/4 is the same thing as negative 0.75. And let me turn this on here, my calculator. And the square root of 7 divided by 4. .66. So this ordered pair right here would be negative 0.75. So we'll put a 1 here and or a negative 1 here and a 1 here and a negative 1 here and a 1 here. So negative 0.75 would be over about right here, then up 0.66 about right there. So there's the ordered pair. Now if we were to reflect it across the x-axis or across the y-axis over to there, then we'd end up with going over positive 0.75 and positive 66. So the ordered pair would be positive 0.75, positive 0.66. Take this ordered pair and go down, then we would have a negative 0.75 because we're still to the left of the origin, and negative 0.66 because we went down. Now if we put the ordered pair over here, notice it would be a positive 0.75 because we're to the right of the origin, and a negative 0.66 because we're down. This point here, we reflected across the y-axis. This point here, we reflected across the x-axis. And this point here, we reflected across the origin. All right, number 2. Let's go ahead and do the exact same thing. Excuse me. All right, this would be 0.4, 2/5, and the square root of 21 divided by 5 would be 0.92. So again, we'll put a negative 1 here, a 1 here, a 1 here, and a negative 1 here. So we go 0.4, that's about right here, then up 0.92. So there's your ordered pair. Now if I were to reflect it across the y-axis, it would be right here. And so that would be a negative 0.4, right? Because we're to the left of the origin, then up. So a positive 0.92 over and up. Now if we were to reflect this point across the x-axis, it would be right here. Now your x value is to the right, so it would be a positive 0.4. And it's down, so it would be a negative 0.92. And then if we were to reflect this point across the origin to right here, excuse me, that's not right, to right here, then I would be to the left of the x-axis, so negative 0.4, and I would be below the origin, so negative 0.92. I hope that helps. Okay, let's continue on. Let's take a look now at number 5. The number pi over 4 determines a point on the unit circle with those coordinates. What are the coordinates of the point determined by negative pi over 4? Okay, well, let's take this step by step instead of freaking out. Let's first of all draw a coordinate plane so we can get a picture of it. And pi over 4 determines a point on the unit circle. Square root of 2 over 2, square root of 2 over 2. Let's get a decimal on that very quickly. Divided by 2, it would be 0.71, 0.71. So what it's saying is simply this. We're rotating up pi over 4. There we go. And we have an ordered pair right here. And that ordered pair is 0.71, 0.71. Now, if we had, let me read the problem exactly. What are the coordinates of the point determined by negative pi over 4? Well, students, that's not that difficult, really. I mean, in other words, negative pi over 4 would rotate like this, correct? It would rotate down. So there's negative pi over 4 right there, negative pi over 4. And so now that point would be right here. So obviously your x value would still be positive, 0.71, and so we went to the right, and then the y value would be negative, so negative 0.71. You just reflected it across the x-axis. That's all that you did. Okay? All right, moving on to number 7. Number 7 through 23 odd they're asking us to find the exact find the function values using exact numbers or exact answers. So let's start with the sine of pi. Are you ready? Sine of pi. Well, the first thing we do, we really should pause, to be honest with you students, and let's get our special triangles drawn. I think that'd be very, very helpful. I really do. So there's one special triangle. I don't care if they look the same. That's not really a big deal to me. And now very quickly, let's label these. This would be 45 degrees. Actually, we want to use radians, so sorry about that. This would be pi over 4. And this would be a 1, a square root of 2. This would be pi over 6. This would be pi over 3 for 60 degrees. And this would be a 2, this would be a 1, and this would be square root of 3. Now we're ready to roll. Okay, sine of pi. Well, do you see pi in any of these triangles? No, you do not. So we know we're going to have to find a reference angle. So pi. Oh, this is interesting. Look, it lands right here. Remember, this is pi over 2, 90 degrees, and pi is 180 degrees. So, boom, right on the axis. Remember what I've told you, when you have an axis angle, you're welcome to use your calculator. So make sure you're in radians now. Make sure you're in radians, your mode. And then go ahead and type in sine of pi. And you will get 0, 0. That's definitely an exact answer. Definitely an exact number. All right, now let's go back a page real quick. And let's go ahead and see if we can't attempt to cut and paste this from now on. I think that'd be a big help if we could do that. It'd be a little sloppy here. I apologize. I should have done this a little better. But anyways, let's go back. And now if I can slide it down out of the way. There we go. It's a little better. Okay, now, let's see. My 1 did not take there. Okay, cotangent of 7 pi over 6. Now, I don't see 7 pi over 6 in any of my triangles, so I'm going to find the reference angle. So I know if I go like 7 pi over 6, guys, is 1 and 1/6 pi. 7/6 pi, or 7 pi over 6, is 1 and 1/6 pi. So I'm going to go 1 whole pi and then a 1/6 more. So if I go a 1/6 more, then that's my reference angle right there, pi over 6. So I'm in this quadrant. My sine sequence goes negative, negative, positive. Now you're more than welcome to take cotangent of pi over 6. That's totally fine, okay? Instead of 7 pi over 6, as long as you remember that cotangent is positive in this region. Sine, cosine, tangent, so positive. Now let's go ahead and take the cotangent of pi over 6. Here's pi over 6 right here. Cotangent is the inverse of tangent. Now, tangent is opposite over adjacent. So cotangent would be adjacent over opposite. Adjacent, square root of 3 over opposite. So square root of 3 over 1, or just square root of 3. All right, number 11. Sine of negative 3 pi. Well, there's no negative 3 pi in your triangle, so let's get an idea of what's going on here. Negative 3 pi. Now remember, 1 whole revolution is 2 pi, so there's 2 pi. And then if I go a half a revolution, that's 1 more, that'd be 3. So look, I'm hitting an axis angle. So it's okay to use your calculator. So make sure you're in radians and type in sine negative 3 pi. Sine negative 3 pi, and you will get 0. The answer is 0. Okay? If you're wondering where the pi button is, look to the far right side of your calculator. You'll see the clear button, C-L-E-A-R. Right below that, you'll see an arrow button. If you hit second and then arrow button, up will pop pi. All right, number 13, cosine of 5 pi over 6. Now, notice in our special triangles, there is no 5 pi over 6, and so we're going to have to look for a reference angle. Now 5 pi over 6 is the same thing as 5/6 pi. We know if we go all the way to here, 180, that's pi, so we know we're not going to go that far. We're going to go 5/6 pi. If I go 5/6, that leaves me with 1/6 right here, 1/6 pi, or pi over 6. So my reference angle is pi over 6. Now, I'm in this quadrant here, which is positive, negative, negative. So you are more than welcome to take the cosine of pi over 6 instead of 5 pi over 6, as long as you remember that the sign of cosine here is negative. There we go. Now, cosine of pi over 6, here's cosine right here, here's pi over 6. Cosine is adjacent over hypotenuse, adjacent over hypotenuse. So, square root of 3 over 2. Negative square root of 3 over 2. Number 15, secant of pi over 2. Now, we do not have pi over 2 in any of our triangles, I don't believe. And so we are going to go ahead and draw our find our reference angle, So pi over 2. Boom, right there. That's it. 90. That's an axis angle right there. So we're going to have to take, we can't take secant of pi over 2. So we're going to, the inverse of secant is cosine. So I'm going to take the cosine of pi over 2 and then invert it, okay? So cosine and then pi divided by 2. I get 0. Now think about this, guys. If cosine of pi over 2 is 0, in order to find the secant, I have to flip this. Well, if you flip 0, you get undefined or no solution. So, Mr. Earhart, you're telling me that we cannot take the secant of 90 degrees or pi over 2? That's exactly right. You can't. It's undefined. I'm not going to get into why now, but there is a reason. And so if you have 0 and you flip 0, it's like having 0 over 1. And if you flip that, you get 1 over 0. And you can never have 0 in the denominator. So the answer is undefined. Number 17, pi over 6. Now this is already in our special triangle. So we're really okay here. I mean, it's not going to take any reference angle. Cosine of pi over 6. Well, here's pi over 6. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So simply square root of 3 over 2. That was easy. All right, number 19. We do not have pi over 4 in our special triangles, so we're going to have to find the reference angle of 5 pi over 4. Now, remember, 5 pi over 4 is the same thing as 5 fourths pi, which is the same thing as 1 and 1/4 pi. So we're going to have to go around 1 and 1/4. Okay, so here's our coordinate plane. We're going to go 1 pi, that's right there, and then a fourth. So my reference angle is going to be 1/4 pi or pi over 4. Now don't forget, in this quadrant, the sign sequence is negative, negative, positive. So instead of taking sine of 5 pi over 4, we are definitely going to take the sine of pi over 4, as long as I remember that in this quadrant, sine is negative. Sine is negative. So I'm going to put a negative sign right here. And now sine of pi over 4, here's pi over 4. Sine is opposite over hypotenuse. Opposite over hypotenuse. So 1 over square root of 2. And of course, we never want a radical in the denominator, so we're going to multiply the top and the bottom by square root of 2. That's negative square root of 2 over 2. All right, hope that helps. Moving on to number 21. Sine of negative 5 pi. Now, obviously, 5 pi is not one of our angles in our special triangles, which is fine. So we're going to go ahead and try to find a reference angle. So negative 5 pi. When we go around once, that's 2 pi. Go around again, that's 4 pi. And then remember, if you go to 1a, that's 1 pi right there, so that's 5 pi. Oh, look, we're right on the axis. So you're welcome to use your calculator. So simply type in sine of negative 5 pi, and you will get 0. Easy enough. The calculator problems are the easiest ones. Number 23, cotangent of 5 pi over 2. Now notice 5 pi over 2 is nowhere in our special triangles, so we're going to have to find the reference angle. So 5 pi over 2 is the same thing as 5 halves pi, which is the same thing as 2.5 pi. 2.5 pi. Okay? So I'm going to go around 2.5 times. Let's see what happens. So I go around once, that's 2. And then don't forget, 90 degrees is half a pi, so a half a pi. Oh, I'm right on the axis. So I can use my calculator. So I'm just going to type in, oh, I can't type that in, can I? I'm going to have to type in the tangent of 5 pi over 2, and then whatever I get, I'm going to have to flip it. So tangent 5 pi divided by 2. and I get undefined. This will be interesting. This will be a good problem. So the tangent of 5 pi over 2 is undefined. Now, if that's undefined, when you flip undefined, you get 0. Just trust me, undefined really means what you have here is 1 over 0. So if you flip undefined, because we're trying to find the cotangent, we found the tangent of 5 pi over 2. Now to find the cotangent, we have to take our answer here and flip it. Well, if you flip undefined, you get 0. So the cotangent of 5 pi over 2 is 0. All right, number 25, tangent of pi over 7. Oh, now we're into calculators. Okay, numbers 27 through 41 are all calculator problems. We are loving this. Make sure you're in the radian mode, and I'm simply going to type in tangent, pi divided by 7, and I'll get 0.4816. 0.4816. Number 27. Now I'm going to type in the cosine, not the secant, because I don't have secant on my calculator. The cosine, make sure you're in radians. Now there's no degree circle. I know you think it's degrees, but it's not. It's radians. So type in the cosine of 37, enter, and you'll get this right here, 0.76541400519, and then just simply hit the x to the -1 button. Look all the way to the left, fourth button down from the bottom, x to the -1. Just push that button, and this will pop up on your screen. Answer to the -1, and then hit enter. What you did is you flipped it. So you found the cosine of 37 was this, and then when you typed this into your calculator, it flipped it for you, and you got out 1.3065. Cool. 29, cotangent of 342. Okay, we're going to type into our calculator's tangent of 342. Now, if you're missing these, you're probably not in the radians mode. Make sure you're in radians, and you'll get this right here, negative 0.4629845265. Now flip that, hit x to the -1, and this will pop up, answer to the -1, and then hit enter, and you should get negative 2.1599. Okay, and that would be the correct answer. Moving on to 31. Cosine of 6 pi, we'll simply type in cosine of 6 pi, and you will get 1. The answer is 1. Easy enough. Moving on to 33. Well, we can't use cosecant on our calculator, but what's the inverse of cosecant? Well, sine is the inverse of cosecant. So we're going to take the sine of 4.16, and if you type that in correctly, and if you're in the radians mode, you will get negative 0.85127340009. Then hit the x to the -1 button, and this will pop up on your screen right here, and then hit enter, and you'll get negative 1.1747. All right, let's continue on. Number 35, tangent of 7 pi over 4. We'll simply type in tangent 7 pi over 4, and you will get -1 as long as you're in the radian modes. Number 37, sine of negative pi over 4. Simply type that into your calculator. Hit sine, then the parentheses pops up. Negative pi divided by 4. Close your parentheses. And you'll get negative 0.7071. And then moving on to number 39, sine of 0. We'll just type in sine of 0. That's easy. Sine of 0, hit enter, and you will get 0. And then number 41, type in the tangent of 2 pi divided by 9, and you will get 0.8391. Okay, so pretty cool, and we are moving on. Let's go back up to the top and see where we're at here. Now we're going to page 454, so go ahead and turn over to page 454, please, if you would, and we're going to do numbers 8 and 10. Numbers 8 and 10. Okay, the directions say to solve the right triangle. That means we're going to solve for all the missing parts. Right now we know 3 parts. We know the right angle is 90, and we know 2 sides, A and B. Well, look, students, if I'm missing C, if I know 2 sides, I'm going to use Pythagorean Theorem right off the bat. So 12.5 squared plus 18.3 squared equals the hypotenuse squared, C squared. Now, you guys should be pretty handy by now with your calculators, okay? So if you take 12.5 squared plus 18.3 squared and add those 2 numbers together, you will get 491.14. If you're not getting that, check your work, okay? And then take the square root of both sides. If you take the square root of c squared, you'll get c. If you take the square root of 491.14, you'll get 22.16. So there, we have now found c, 22.16. So now we know all 3 sides, don't we? And we know one angle. We just got to find the two others and we're home free. Now, I don't care which angle you want to find. It's up to you. Let's go ahead and find A. And since you know all three sides, I don't really care. Since you know all three sides, I don't really care if you use sine, cosine, or tangent to find your angle. I'm going to use sine just because I feel like it. So sine of angle A equals opposite. Well, that's A, 12.5, over hypotenuse, C, 22.16. Now, I've taught you this before, guys. When you're looking for the angle, that's when you hit second sine on your calculator, and up pops sine to the -1. But hold it, I just thought of something. You're in radians, and they're going to want your answers here to be in degrees. So you better go back to your mode right now. Scroll down, go over and hit degrees, and change to degrees. And now we're ready to go. Hit sine to the -1, so second sine. And when you do, this will pop up. And then type in 12.5 divided by 22.16. If you do that correctly, you will get the correct answer for angle A, which will be 34.3 degrees. So now we know angle A is 34.3. Now look, if we know this angle is 34.3 and this angle is 90 degrees, well, we know all three angles have to add up to 180. So very quickly, add 34.3 plus 90 to get the sum of those two angles, and that'd be about 124 point something, and then subtract from 180, and the leftover angle would have to be 55.66. And that does make sense totally. If you were to add up those three angles, you would get 90 degrees. All right, number 10. Now, number 10, they give you, we know two angles. We know B right here is 56.5. They give that to us. We know C is 0.0447. But here's B, 56.5. We know this is 90 degrees right here. So I'm going to add those two together. Excuse me for yawning, sorry. And when you add them together, you get 146.5. And then subtract from 180. And that will give you 33.5 for this angle. So now we know all three angles. Very good. Now, we got to find the missing side. Now, please watch this, student. I don't care which angle you choose, guys. You can choose 33.5. You can use 56.5. I don't care. I'm using this angle only because I feel like it. There's no shortcut, okay? Now, I could use tangent. I'm trying to find one of these missing sides, A or B. I could use tangent, but that's a mistake. Watch what happens. Tangent of 33.5 equals opposite over adjacent, A over B. That's two unknowns. I don't want two unknowns. That's going to be a mess. So what I'm going to say is tangent. I'm not going to use tangent at all. I'm going to use something like cosine or sine. So let's try sine. Sine, you could use cosine also. Either one's fine. Cosine of 33.5 equals opposite, that's A, over hypotenuse, 0.0447. Now we're trying to solve for A. What I've taught you to do is multiply both sides by the bottom of the fraction. So if you multiply the left side by 0.0447, you get 0.0447 sine of 35.5 equals A. And now type this whole thing into your calculator right here. A equals this whole expression. So type in 0.0447 and then hit sine and then 35.5. Make sure you're still in the degree mode. Hit enter. And for A, you will get kind of a weird number, but it makes sense because your hypotenuse is 0.0447. You get 0.0260. So 0.0260. Now students, look, you do what you want. When I know two sides of a right triangle, I just use Pythagorean Theorem. So one leg is B, that's B squared. The other leg is 0.0260. We're going to square that. And then the hypotenuse is 0.0447 squared. Now, if you square 0.0260, you will get, actually it's a really weird number. I'll go ahead and write it. It's point and then 3 zeros, 1, 2, 3, and then 676. Over here, if you take 0.0447 and square it, you're going to get 0.001998009, and then subtract this, bring this over. We're solving for b, so bring over 0.000676. And subtract it, and you will get 0.00132209, and then take the square root of both sides. If you take the square root of, hold on one second please, thank you. If you take the square root of b squared, you'll get b. If you take the square root of this right side here, you will get 0.0364, or just 0.04, or 03 is fine, okay? All right, that's numbers 8 and 10, so we are definitely cruising right along, setting some land speed records. Now we're looking at page 471. So go ahead and turn over there, please. Page 471. I'm going to grab a quick drink of water here. There we go. And please turn over to page 471, and let's look at these problems here that we have listed. All right. All right, let's start off with number 2. The directions for 2 says state the quadrant the terminal side lies in. Well, this is cake for you guys. This is easy. Negative 14.3. This is all degrees, so this would be 90 here if I went downwards. So there we go. Negative, go down 14 point, about right there. So the terminal side would lie in the 4th quadrant. Don't forget, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay? So if it's negative 14.3, we would go this direction down, 14.3, and we're in the we're in the 4th quadrant. All right, number 4, the directions are still the same, negative 120. So we're going to rotate down 90 and then 30 more, which puts us right here in quadrant number 3. 1, 2, 3, quadrant 3. All right, next is number 10. Now, I really don't need all these minutes and seconds, do I, students? Think about it. If I know it's 13 degrees, I mean, I know it's less than 90. I'm gonna have to go higher than 90 to get past 90 here, okay? And I'm not higher than 90. I'm not larger than 90 degrees. I'm just 13 degrees. So I'm just going to rotate up about 13 degrees, and your terminal side would obviously lie in quadrant 1. All right, the directions for 14 state. Find 2 positive angles and 2 negative angles that are coterminal with the given angle. Here we go. Concentrate now. Watch me, please. So my original angle is negative 81. Got it? So I'm going to rotate down. There we go. I'm going to draw my angle, 81 degrees. Very good. Now, they want 2 positive coterminal angles. So here's one. Start here and go to there. Got it? That's not quite to 360. You're 81 degrees short of 360. So I'm going to take 360 degrees and subtract 81 degrees. 360 minus 81 with my calculator would give me 279. So this motion that I made right here, that angle right there, is 279 degrees. All right? So 279 degrees. Now let's find another positive coterminal angle. Now in order to do that, I'm going to have to go around once and then all the way to here. So basically, I went around once. That's 360 degrees, right? And then after I went around once, then I went 279 degrees again. So it's basically 360 plus 279. So 360 plus 279 would be 639 degrees. 639 degrees. Now they want 2 negative coterminal angles. Well, I can't just go like this. That's negative 81. That's the same angle I started with. So I'm going to have to go around once. That's 360. And then 81 more degrees. So 360 plus 81 is going to be 440. Now it's negative, don't forget, because we started down and went around. So negative 441 degrees. Now, we have to find another negative coterminal angle. So we're going to go around hold on one second, please. Thank you. Oh, okay. I got it now. We went around once, then 81. So now we're going to have to go around twice. So we start here. We go once, twice. That's 720 degrees, 360 and 360. So we went around once. That's 360. Once again, that's 720. And then 81 more degrees. So we basically have 720 plus 81. And don't forget that we did go downward and around. So it would be a negative 840 201 degrees. All right, that's number 14. Number 16, 275 degrees and 10 over 60, which is the same thing as 1/6. So we're looking at 275.17. So 275.17. Now let's get a picture of this angle here. 275, whoa, hold on a second. I think I just yanked out the speaker cord. Hope you guys can still hear me okay. All right, 275 degrees. Let's see, here we go. Well, that's 270. I mean, think about it, students. 90, 90 more, 90 more. That's 270, then a little bit more. So there we go. That's 275. So let's find a positive coterminal angle. I would go one rotation, that's 360, and then I would go to the terminal side, that would be 275.17. So I basically have 360 plus 275.17, and you will get 635.17. And now, let's go ahead and do this again. We'll go around once, that's 360, and again, that's 720, and then add on the 275.17 as you go to the terminal side right here. So there we go. So we're looking at 360 or 720, 360 plus 360, so 720 plus 275.17, 995.17. Now, let's see if we can't find some negative coterminal angles. We would start here and go down to the terminal side. Boom, right there. Now think about it. If from here to here is 275.17 and all the way around is 360, all I have to, we didn't quite get all the way around. I'm just going to take 360 and subtract 275.17, and we will get 84.83. Now don't forget, that's negative 84.83, negative, because we went downward. Now let's find one more negative coterminal angle. Obviously we have to go around one rotation, that's 360, and of course then go again this 84 degrees from here to here. So it would be 360 plus 84.83, and that would be negative because we rotated down and not up. So it's going to be negative 444.83. All right, grab a quick drink of water here again. And let's see what's next here on the agenda. Number 20. Find the complement and the supplement. Okay, no problem. We would have what? 47.63. So, to find the complement, we take 90 minus this angle. So, 47.63. 90 minus that angle. And the complement would be 42.37. And then to find the supplement, we take 180. And we subtract out that angle. And you'll get 132.37. And this angle here is the supplement for this angle right over here. All right, number 26. Now, number 26, they want us to find all 6 trig functions for this ordered pair that lies on this this ray here. Okay. Now, what I'm going to do is I'm going to go ahead and draw a right triangle coming down like this, and draw one coming across. Okay. In fact, I'm just going to go ahead and make it a solid triangle coming there, and coming down. Now, this ordered pair right here, to get that ordered pair, I had to go over square root of 7, so I know this side is square root of 7, and I had to go down 3, so I know this is 3. So now I can draw that triangle off to the side. The triangle looks like this. And I know I can put square root of 7 here, 3 here, a right angle here. And now to save time, I'm not going to find I'm not going to use Pythagorean's theorem. I'm going to use it, but I'm not going to show you how I did it. I mean, really by now, guys, we should know leg squared plus leg squared equals hypotenuse squared. And if you do all the work here, you get 16. So take the square root of both sides. 4 equals h. Okay, so using Pythagorean's theorem, I now know all sides of this right triangle. It's 4. Okay? Now, the only thing you got to remember is you're in the fourth quadrant, and the sine sequence goes negative, positive, negative. Okay? Please don't forget that. And we're taking the sine of this angle right here. We'll call it angle x. I'm going to put an x right here. Okay? That's the angle. So go straight across. That's your opposite. This is your hypotenuse, and this is your adjacent side. So I'm going to go really fast, okay? The sine, we're going to call it x. The sine of angle x is opposite over hypotenuse, 3/4, but it would be a negative 3/4 because we're in the fourth quadrant. And I'm going to go ahead very quickly and just put the cosecant here too underneath it since they're inverses. The cosecant would be negative 4/3. Okay, next I'm going to do cosine. Cosine would be adjacent over hypotenuse, so square root of 7 over 4. And cosine is positive in this quadrant. The inverse of cosine would be secant. So the secant of x would be 4 over square root of 7. Rationalize, multiply the top and the bottom by the square root of 7. We get 4 square root of 7 over 7. Tangent of x. Tangent is opposite over hypotenuse. Opposite over hypotenuse, 3/4. And tangent is negative in this quadrant, so negative. And of course, the cotangent is just the inverse of that. So the cotangent of x would be negative 4/3. Okay? Not too bad, really, as long as you just find the missing side in the triangle and then go from there. Okay, moving on to number 28. Number 28. All right. Well, we're in the first. This is pretty simple, guys. We're in the first quadrant, so we know everything's going to be positive. I'll go ahead and draw the right triangle. You come down, you go over. We know to get to this ordered pair right here, we had to go over 9, so that's a 9. We had to go up 1, so that's 1. 81 plus 81 is 82, so the hypotenuse here would be square root of 82. Now, really technically, guys, I'm not sure how much they want you to break down the square roots. We've not covered that a whole lot. I'm going to go ahead and draw your triangle here off to the side. Here's your triangle that you have, and here's your right angle. And this is square root of 82. And this is 9, and this is 1. Okay, this is our angle down here. Call it angle x. So angle x. So, not cosine. The sine of x would be opposite over hypotenuse, 1 over the square root of 82. 1 over the square root of 82. So if we invert that, we get the secant, or the cosecant. Cosecant of x would be square root of 82 over 1, or just square root of 82. Back up here, we got to rationalize this. Multiply the top and the bottom by the square root of 82. You would get square root of 82 over 82. All right, sine, cosine, cosine of x. Cosine of x would be adjacent over hypotenuse, so 9 over square root of 82. So then the inverse of cosine is secant, and the secant would be square root of 82 over 9. Now up here we multiply the top and the bottom by the square root of 82, and if we do that correctly we get 9 square root of 82 over 82. Alright, and then sine, cosine, tangent. Tangent of angle x would be opposite over adjacent, so 1/9, and so the cotangent of x would be 9 over 1, which is 9. All right, that's number 28. Moving on to number 30. Now, it's a pretty tough one. I know that, but let's see how we do here. Okay, we know we're going to be in quadrant 2. That's what it says. So we know we want to have a line that goes up like this from quadrant 2. All right, and all we have to do is find an ordered pair that lies on that line. Now, look, you're over here in this quadrant. So the x values you want to use should be negative x values, okay? I'm going to use -1 just to make it as small as possible. So you know what I'm going to do? I'm going to put -1 in for x. Now you could use any number you want as long as it's negative. If you put a positive x in, that means you're over here somewhere. in this quadrant or this quadrant. And that's not where we're at. We're over here in this quadrant. So use negative numbers. I'm going to use -4 or -1. 4 times -1 plus y equals 0. 4 times -1 is -4 plus y equals 0. Bring the -4 over and make it a +4. So it looks like to me, when I put -1 in for x, I get 4 out. So I can go over -1 and then up +4. So my ordered pair is -1, 4. -1, 4. Now we'll go ahead and draw our right angle, so our right triangle. So there's our triangle. And we know that I went over 1 and up 4. Over 1 and up 4. And so that's going to be the 17, the hypotenuse would be the square root of 17. And here's your angle x right down here. So it looks like this. Here's your right angle. Here's angle x. Here's 4. Here's 1. Here's square root of 17. And now, for number 30, it says find the sine, cosine, and tangent. So very quickly, the sine of x would be opposite over hypotenuse, 4 over square root of 17. Rationalize, and we would get 4 square root of 17 over 17. Cosine of x, adjacent, which is 1 over hypotenuse, so 1 over square root of 17. Rationalize, and you'll get square root of 17 over 17. And then the tangent of x is opposite over adjacent, 4 over 1, opposite over adjacent. Opposite is 4, adjacent is 1. Another water here. Hold on 1 second. Okay, I never get to talk this much. I'm married. Just kidding. Shouldn't say that. All right, moving on. Number 32. Number 32. All right, we know we're in quadrant 3. We know we're in quadrant 3. It really doesn't matter what you put in for x. I just don't want a decimal, you know? I mean, I'm thinking 10, because if I put a 10 in for x, I'll get out of 8. And of course, if I put a 5 in, I get out of 4. See, 2, 3. I'm going to put a 5 in. Okay, look, guys, we're in quadrant 3. Actually, I've got to put a negative number in. We're over here in quadrant 3, okay? Do you see that? Quadrant 3. 1, 2, 3. So we're in quadrant 3. Now, I know if I put in a positive x value, I'll be over here in this quadrant or this quadrant. And that's not where I am. So I'm going to put a negative number. I'm going to use negative point. I'm going to use negative 5. Y equals, I'm going to put negative 5 in for x. That'll give me out a non-decimal because I put a negative 5 in for x. So y would equal negative 4. So there we go. So our ordered pair is I put in negative 5 and we're down negative 4. So there's the ordered pair. I put in negative 5 and I got out negative 4. There's your ordered pair. So my triangle will look like this. There, 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 and there. I go over 5, down 4. There's your right angle. So I'm going to draw it over here. Here's your right triangle. There's your right angle. This length here is 4. This length here is 5. Here's your angle x right here. Here's your angle x. And now using Pythagorean's theorem, oh dear, we would have 16 plus 25. Oh, that's not what I wanted. That would give us 41, so the square root of 41. So here we go. Sine of x, opposite over hypotenuse, 4 over square root of 41. Rationalize, you'll get 4 square root of 41 over 4. Cosine of x would be adjacent, 5 over hypotenuse, square root of 41. Rationalize the fraction, and you'll get 5 square root of 41 over 41. And then we're looking at the tangent of x, and the tangent of x is opposite over adjacent. Opposite is 4, adjacent is 5, so 4/5. Moving right along. We're doing really well, actually, guys. Let's see how many more we have left to do here. We've done 32, so not too bad. Not too bad at all. All right, moving on to number 34. Number 34. Okay, students, they're giving us one bit of information. The tangent of b is 5, or we could say 5 over 1, right? We could. So tangent of b is 5 over 1. Tangent is opposite over adjacent, so now we know two sides. We know the opposite side is 5, and the adjacent side is 1. So we know we're in quadrant 1. Here's quadrant 1. So we draw our angle going up. We don't care how big it is. There it is. We'll call this angle B. And we draw our right triangle down. And we know opposite is 5, adjacent is 1. So this would be square root of 26. And now they want us to very quickly find the other function. So here we go. Sine of B would be opposite over hypotenuse, 5 over square root of 26. And so the cosecant would be square root of 26 over 5. Up here we have to rationalize, so we would get 5 square root of 26 over 26. All right, cosine of B would be adjacent over hypotenuse, so 1 over square root of 26. So the inverse of cosine is secant, and so we would get the square root of 26 over 1, or the square root of 26. Here we have to rationalize, so we'd end up with the square root of 26 over 26. Now the tangent of B would be opposite over adjacent, so 5 over 1. So the cotangent would be 1 over 5. The cotangent of B would be 1/5. All right, let's take a look at number 36. Now here we're in the second quadrant, so let's be careful here. Second quadrant. Let's go back a page, shall we? What quadrant were we in? The first quadrant. Good. Okay. That's really a bad drawing. Okay, here we go. Okay, we're in quadrant 2, so we'll draw our line going up, our triangle coming down. We're in quadrant 2. Now, cosine is what? Adjacent over hypotenuse. So here's your weird looking angle, whatever that symbol's called. All right. We know adjacent right here would be 4. We know the hypotenuse would be 5. If you did Pythagorean Theorem, you would get a 3 right here. Now watch your sign sequence. You're not in the first quadrant. You're in the second. It's positive, negative, negative. So here we go. So I'm just going to call this x to save time. Okay. Sine of x equals opposite over hypotenuse, 3/5. And it is positive in this quadrant, so the cosecant would also be positive, and the cosecant of x would be 5/3. Now, the cosine of x would be adjacent over hypotenuse, 4/5, but it would be negative because cosine is negative in this quadrant, and its inverse then would also be negative, so the secant of x is negative 5/4. Now, the tangent of x would be opposite over adjacent, so 3/4, and it would be negative because tangent is negative in this quadrant, and so tangent's inverse, cotangent, would also be negative. Cotangent of x is negative 4/3. And then lastly, number 38. On number 38, we realize we are in the third quadrant, so we go down to the third quadrant right here, and we draw our right triangle. And it's because it's sine, we know this is opposite, and we know this is hypotenuse. So here's my angle. We're going to call it theta. Opposite is 5. Hypotenuse is 13. So let's see what we got here. We got 169 minus 25, 144. If you use Pythagorean Theorem, you will get 12 right here. Now watch your sign sequence. It's negative, negative, positive. So the sine of theta is opposite over hypotenuse, 5/13, so it would be a negative 5/13. And the inverse of sine is cosecant. So cosecant would be negative 13/5. Okay, cosine of theta would be adjacent over hypotenuse, and cosine's negative in this quadrant, so negative 12/13. And the inverse of cosine would be secant of theta, negative 13/12. Now, the tangent of theta would be opposite over adjacent, so 5/13. Excuse me. No, that's incorrect. It would be 5/12. 5/12 opposite over adjacent, so we would be looking at 5/12. And tangent's positive in this quadrant, so positive 5/12. And the inverse of tangent is cotangent, so the cotangent of theta would be 12/5. Okay, we're moving right along. Let's continue on now and take a look at number 40. Thanks. Okay, secant of negative 225 degrees. We do want exact answers. So here we go. Negative 225. I wonder if I still have my triangle saved. Oh, I do. Lovely, lovely. All right. Now we're going to convert this over to degrees. So this would be 45 degrees, and this would be 30 degrees, and this would be 60 degrees. All right. All right, here we go. Now, let's find the secant of negative 225. So be careful. I go around negative 180 and then 45 more degrees. So my reference angle right in here would be 45 degrees. So instead of finding the secant of negative 225, I'm going to find the secant of 45 degrees. But what is secant? Secant is the inverse of cosine. Cosine's negative in this quadrant, so secant of 45 would be negative. Now here's 45. Cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent, so square root of 2 over 1, or just square root of 2. Okay, number 44, tangent of 270. We'll go ahead and get our special triangles up here. So very quickly, 270 is not in my triangle, so I'm going to go 90, 180, 270. Notice it's right on the axis, so you're more than welcome to use your calculator. So tangent of 270 is undefined. You should get undefined on your calculator. It does not work. All right, moving on to number 48, sine of 300. Now, we go ahead and put our special triangles up here like this. And there we go. Sine of 300. Well, let's see what we got here. 300 would be 270 plus 30 more. So if I went 300, I'm left over with 60 on the inside. Now, sine in this quadrant is negative, so you're more than welcome to use the sine of 60, okay, as long as you remember it's negative. Now, 60 is right down here. This is 60 degrees. So the sine of 60 would be opposite over hypotenuse, square root of 3 over 2. So negative square root of 3 over 2. Okay, moving on to number 52, cotangent of 855. Now, first of all, we know that 855 is none of special angles, so I've got to go around the thing here quite a few times. So once is 360, again is 720. Then that's okay. We'll go 90 degrees, and that would be 810, and then 45 more degrees. So if I went 45 more degrees, then what I'm left over with right in here would have to be also 45 degrees, because here's 45 and that's 45. So cotangent in this quadrant is negative, so you're more than welcome to take the cotangent of 45 degrees, as long as you understand that's going to be negative. Now the cotangent, this is 45 degrees right here. Cotangent is adjacent over opposite, so, or adjacent over opposite, so 1 over 1, which would be 1. So 52 would be negative 1. Moving on to number 56, the cosecant of 90. Well, guys, you know that's going to be a quadrant angle. I mean, 90 is, or an axis angle. It falls right on 90. So instead of taking the cosecant of 90, I'm going to type in the sine of 90. And if I do that, I'm going to get 1. So if you invert 1 or flip 1 or find the inverse of 1, that's still 1. 1 over 1 is 1. So the answer is 1. Now, sine of 1050, this is pretty much, I think it's a pretty ridiculous problem, to be honest with you. I don't understand why they want you to go around so many times, but that's fine. We'll go ahead and do it. You would have to go around 3 times, or 2 times. So you go around once, that's 360, again that's 720, and you have 330 left, so go 330, and if you go 330, then you're left obviously with 30 right here left over inside the triangle for your reference angle. So there we go. Sine in this quadrant is negative, so sine of 1050 is the same thing as sine of 30, as long as you make it negative. And of course, using our special triangles here, it looks like the sine of 30. This would be the 30 right here. Sine of 30 is opposite over hypotenuse, so it would be negative 1/2, opposite over hypotenuse. Moving on to number 64, tangent of 480. Again, we're going to go around once, that's 360, and then 90, that's 450, and then 30 more. If I go 30 more, then I'm left over with 60 inside the triangle, so my reference angle is 60. Tangent is negative in this quadrant, So the tangent of 60 degrees would be negative. And now let's see what we have. Here's 60 degrees. Hold on 1 second, please. All right, 60 degrees would be right here. So the tangent of 60 is opposite over adjacent. Square root of 3 over 1, so negative square root of 3. Number 68, sine of negative 135. All right, well, we go down 90 and then 45 degrees more. So I'm left over with 45 degrees here. And sine is negative in this quadrant, negative. So the sine of negative 135 is the same thing as sine of 45 as long as I make it negative. So let me drag this down here. And let's see what we have here. The sine of 45 degrees would be opposite over hypotenuse. So 1 over square root of 2, which would be negative square root of 2 over 2. Okay, moving on to number 72. All they want us to do here is find the sines. This is so easy. They want us to find the sines for sine, cosine, tangent, cosecant, secant, and tangent. Just the sines. So negative 57 degrees would put us in this quadrant right here. So we're in quadrant 4. The sine sequence here is negative, positive, negative. So sine is negative, so cosecant is negative. Cosine is positive, so secant will be positive. Tangent is negative, so this should be cotangent here. So cotangent would be negative. These are pretty easy here. All right, and last but not least, 290. Well, I would have to go around, that's 270, so I'd go a little further. It's the exact same quadrant, guys. You're in quadrant 4, so you get the exact same answer all over again. So really, just to save time, please don't talk about it. I'm doing a video, okay? Hold on 1 second. To save time, guys, all that I have to do is just do this. There. I mean, the sine sequence are still the same. The sine sequence for quadrant 4 is negative, positive, negative. So sine is negative, cosecant is negative. Cosine's positive, secant's positive. Tangent's negative, cotangent's negative. And that's it. And that is the entire review sheet, my young students. And I hope that was a help to you. Hope it gets you ready for your test that's coming up. Continue to work hard and call or email if you have any questions.